Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in pretty much any college mathematics course, please consider subscribing, checking out our playlists, and then watching videos, commenting, liking, sharing those videos. All those interactions greatly help us out and are appreciated. Let's go ahead and take a look at the current video. I want to look at how to solve absolute value inequalities. First and foremost, let me remind you what the absolute value of a real number is. The absolute value of a real number, A, which of course is denoted by using what are called the absolute value bars, just two vertical parallel lines on either side of A, and is the distance from 0 to A on the number line. Therefore, the absolute value is non-negative because distances are always 0 or positive. So even if I take the absolute value of, say, -3, that means the value would be 3 because -3 is 3 units away from 0. Now, let's look at the following example. Let's say I wanted to consider the absolute value of x is less than or equal to 2. Okay? Well, let's look at a number line. And let's go from -3 to 3. Now, let's just pick some random points and see if they satisfy the inequality. How about the number 1? Well, the inequality, the solutions to this would be the values on the number line whose distance from the origin is 2 or less. Well, certainly the number 1 is 1 unit away, so that would be part of the solution set. Same thing with -1. That'd be 1 unit away, so that would be part of the solution set. Same thing with everything between -1 and 1, so that would be all included. 3 would not, because that's 3 units away. So what we want to do before we kind of finish that off is how far can I go in one direction and how far can I go in the other direction? Well, the numbers that are 2 units away or less would be everything between and including -2 to 2. That means that the x values that satisfy this inequality would be greater than or equal to -2 and also less than or equal to 2. And this right here would be your solution set. Of course, another way to write that using interval notation would be square bracket -2 to 2. Okay. Now, let's look at another example. This time, let's consider the absolute value of x. I'm going to change 2 things here. I'm going to take the equality away, which doesn't really change my solution technique very much, just maybe with my final answer. And then I'm also going to switch the inequality. So let's say the absolute value of x is bigger than 1. Let's look at a number line. Once again, let's highlight some specific points. How about the number 1? That's not part of the solution set because the number 1 is 1 unit away, whereas the solutions to this inequality would be those values whose distance is greater than 1 unit away. Well, what's greater than 1 unit away? Certainly 2, certainly 3, but then also any fraction between 1 and 2, or real number between 1 and 2, not including 1, then also between 2 and 3, and then bigger than 3. Okay? Everything over here is at least 1 unit away. Well, if I go to the negative side, -2 is 2 units away, so that satisfies it. -3 is 3 units away, so that satisfies it. -1 is exactly 1 unit away, so that does not. But everything that would be to the left of -1 also satisfies the inequality. excuse me, between -1 and 1, those are all less than 1 unit away, so that's not part of the solution set, and therefore we get x is less than or equal to -1, or x is greater than or equal to 1. I'm sorry, less than 1, strictly less than, strictly greater than. If I write this in interval notation, I would get -infinity, so -1, union 1 to infinity. And this would be my solution set in interval notation. Okay. Now, there's two examples, two concrete examples of the two types of inequalities with absolute values, meaning where the absolute value is less than or less than or equal to a constant, and then over here I've got the absolute value is bigger than a constant. So let me go ahead and look at the two general situations. Here's the two general types of examples. If I have a positive constant c, and then I've got the absolute value is less than c, and it also could be less than or equal to, u of x then is between -c and c. However, if the absolute value is bigger than a constant, then I have to set this up into the following. The values of u of x is less than -c or bigger than positive c. And just to make sure, u of x is just an expression that has an x in it. It could be x, 2x, x plus 4. It could even be quadratic or anything, really any expression that has an x in it. If you're watching this, chances are you're in a beginning algebra, or intermediate algebra, maybe a pre-calc class, and in that case, u of x is probably linear, like x plus 2 or 2x minus 3, something like that. Well, let's take a look at an example of both. So let's solve the absolute value of x plus 3 is less than 2. Okay? Well, the first thing to make sure we identify is which of the two cases is it. Well, notice here the absolute value is less than a constant, which is what I have here in case 1. Absolute value is less than a constant. And the first step, in other words, the step that I take to get rid of the absolute value bars, is to put the expression in between -2 and +2. Okay. So that matches up with this right here. Now, the idea is I want to take this inequality and I want to isolate x. To isolate x, I will subtract 3, but then whatever I do in the middle, I have to do on the ends here. And that would then give x is less than -1 and bigger than -5. An alternative way to write that would be -5 to -1 with parentheses since I have strict inequalities. Okay. Now, before I do a second example, let's sort of revisit this one and look at a number line. Okay, so let me go from -7 to 3. Now what I want to do is let me highlight the solution set. So I'm going to do this one backwards. The solution set is the values between -5 and -1, which would be, so here's 1, 2, 3, 4, 5. Okay, now here's -1, here's -5. Let's look at the middle of that. Notice this, the middle is -3. Well, let's interpret this in terms of distances. Every value that's in between here is less than 2 units away from -3, right? If I think of this sort of like as a radius, if I go from -3, 2 units would be at -1, but the solutions are less than that, less than 2 units away. Same thing over here. Now, if I go back to this original inequality, notice I can write this as x minus -3 is less than 2. That means the distance between these two values is less than 2. So that's an alternative way that I could solve this, just reasoning through it geometrically, is I could say, okay, well, this means that the values of x are less than 2 units away from -3. So if I identify -3 on the number line, I just have to identify what is less than 2 units away. Again, your instructor, professor probably wants to see you using it the algebraic way, but this is just a way that you can do it geometrically. Let's look at another example. Let's look at the absolute value of x minus 1 is bigger than 3. Once again, I could do this geometrically, but I'll do it algebraically. If I just match this up, I've got the absolute value is bigger than a constant, so absolute value bigger than a constant. And what I do is I split it into x minus 1 less than negative 3, or x minus 1 is bigger than 3. So less than the negative, bigger than the positive. Solve each of those two inequalities. This gives me x is less than negative 2. Over here I get x is bigger than 4. And so my solution set would be negative infinity to negative 2, union 4 to infinity. So let's just quickly recap. When I'm solving absolute value inequalities, one of the first things I have to identify is the absolute value less than a constant, or is the absolute value bigger than a constant, because the procedures are different for each of those. Okay? Thank you for watching. Please consider subscribing, and see you in the next video.